back and thanks for joining me again. I'm asbestos attorney Justinian Lane, and this is part 2 of my asbestos video series, Asbestos 101. Last time in part 1, we talked about the asbestos usage prior to 1877, which is kind of when the ancient use of asbestos stopped and the modern era of asbestos usage began, because the Industrial Revolution was underway and they needed a lightweight, strong insulating material that could handle all of that heat. So today in part 2, we're going to talk about how asbestos products are made and what they're used for, including those insulating uses. Now, we mentioned in part 1 that asbestos got all the way from deep inside the earth in the vein of asbestos that you'll see to your right next to that coin. That's a vein of asbestos. The green lines, that's veins of asbestos. And if you didn't watch part 1, you might want to do that now. But we have the space capsules on here because not only was asbestos useful in antiquity, but we even put them in the Mercury and the Apollo moon capsules. How did we get that to happen? We're going to go through that in the video today, including showing the manufacturing process of asbestos with some very little seen films that's about 100 years old. First though, just a quick refresher, asbestos is a generic name that we give to 6 minerals. They comprise 2 families, the amphibole family and the serpentine family. Amphibole family includes actinolite, amosite, anthophyllite, chrysotolite, and tremolite. Of those, the only asbestos minerals that were used very heavily commercially would be chrysotolite and amosite. And then we have chrysotile, which is a member of the serpentine family. And by and large, if someone says asbestos, this is probably what they mean because most asbestos usage was chrysotile. But want to make sure you understand the differences between the two. So we know that asbestos is a mineral and it's in the ground in the rock. How do we get it out? Well, last time in part 1, we showed some clips from about a 100-year-old video made with the U.S. Bureau of Mines and what was then the H.W. Johns Manufacturing Company and today is known as Johns Manville. This is some film footage from various mines and factories that they own, and we're going to go ahead and show this to you so you can understand all the work that went through creating asbestos products. We also learned in part 1 that the Jeffrey mine in Quebec that was owned by Johns Manville put out 700,000 tons of asbestos every year. But to do that, they had to go through 100,000 tons of rock every day. Here's how that process began. It began with explosives, dynamite. This is the Jeffrey mine. You can see the water in there that's still there. And that's the old-fashioned steam equipment. And we're getting ready to put the shot holes so they can put the dynamite in and actually blow up the rock to start taking the rocks away and pull the asbestos minerals out. So let's watch this. I can only imagine how much asbestos dust every one of those charges put in the air. And as you'll hear more about in part 3, asbestos is really only harmful when you're breathing it. It's not something that if you touch it causes problems. It's airborne. That's where the issues come from. So that was the explosives that they use to loosen up the rock. Well, what do they do next after the dynamite goes off? Well, they have to gather the asbestos. Let's see that. And this is literally what they had. Guys going through and pulling fibers out of these rocks. And then those rocks would be the fibers they pulled out of the rocks would be separated and graded. Asbestos fibers are graded based upon their length. The longer the fibers are, the more useful that they are. And the shorter they were, the more likely they'd have to be used as something like filler in plastic or something along those lines. It couldn't be woven. So they've gathered some asbestos out of the rocks, and the next step is to go ahead and load up all of the ore. In part 1, we showed that JM had a 200-ton truck that they would load it in. But back in this was being filmed, it's these old school steam shovels and equipment that you watch it and you can barely believe this stuff worked. But that's the sort of equipment that they were using 100 years ago, literally 100 years ago, to get asbestos. So once they've gotten that done, this is how they dump it into the slip before it gets crushed. So we have to get everything put together, take off to the factories. Just dumping load after load of raw asbestos. Then after the asbestos has made it to that point, it has to get crushed so they can get the fibers. And here's what that looks like. Literally just dumping rocks into a crusher. Now, this is early era crushers, and I've seen some of the later crushers in like the 60s and 70s, and they're building-sized pieces of equipment, huge. But it started with little crushers like this, even though that's still a pretty big crusher. See, the flat screen is how they're used to separate the fibers. These things shake, and then the fibers fall through a series of screens, just like in gold mining. If you've ever watched the show Gold Rush, hey, if it's this size, it'll fall through this screen. If it's this size, it'll fall through that screen. Same principle here with asbestos. Then we go to the factory and we have the cobbing room, and this is where you really get to see the asbestos stuff in action. See all these people in this room just beating on these asbestos fibers, and you see the bag there right in front of it. Here we go. Look at this, just smashing these things up. No respiratory protection whatsoever, all day banging down on these rocks, getting the fibers out. So after the asbestos is mined, it has to go to the factories, and that's where they start actually producing the asbestos products. And the old school factory footage here is simply fascinating in how they used to do this. So now they're crushing the fibers at the factory, and those would have been probably 50-pound burlap sacks of asbestos. So 6,000-pound rollers. That must have been very difficult to build 100 years ago. So let's watch what this does. Just crushes that asbestos. So what they do with the rock that they pull out of the earth, they crush it and crush it. Let's see the before and after, 200 pounds. What a difference, right? That's what happens when it's been all crushed down. And the crushing is important to get the fiber out. They had machines called carding machines, and it says that the long fibers are being thoroughly opened. Opening up the fibers is what was necessary to spin them and weave them and do things with them. So let's watch that. And there's raw asbestos coming right off, ready to be woven. And you'll see more about the carding room in part 3 about what a dangerous place this was to work. There was one gentleman who reported he was the only survivor out of 10 people who worked in a room exactly like that, doing that exact job. And considering it looks dusty on this old grainy video, that should tell you a lot, because if you can see the dust in the air, it's at an incredibly highly dangerous level to be around. And I've read stories that in some plants, the dust was so bad that workers actually were breaking windows just to get fresh air in. And the next step after carding is the roving machines. And let's watch how these work. So there goes asbestos coming right off the factory line. And for being 100 years old, this looks like terribly sophisticated equipment. Think about this. This is 100-year-old equipment, and they were able to do this. Again, the asbestos companies were very high-tech companies of their day. This was a high-tech product of its day. And they were very proud of their products. And the best way to show you how proud they were of the products, I think, is to go through some of the early advertising products that they made. I have some nice advertisements I want to show you. We have the slides for viewers who want to download this, but I have the actual ads we're going to put on the overhead camera so we can see that. The first advertisement we're going to show you today is from the Keesby and Madison Company. They were a big asbestos company out of Pennsylvania, and they had this advertisement in the 1920s advertising that their insulation here stayed intact after the fire at Broad Street Station. Broad Street Station was a train station in Philadelphia that had a horrible fire in the 20s, and it was a big deal in the area, obviously, but I think it made some nationwide news as well. And Keesby and Madison was very happy that their product survived. And they talk about that the carded asbestos fiber and their featherweight magnesia covering gives all the needed structural strength and removes the load from the pipelines. So you just saw in the last the videos before these ads what carded asbestos fiber means. Fluffy asbestos fiber that had already been broken apart and then got mixed with this 85% featherweight magnesia. The other 15% is asbestos, probably chrysotile asbestos. So these products were used heavily for insulation. The magnesia covering, it was another one of the early products that was used and mixed with asbestos. Prior to asbestos, people were experimenting with magnesia pipe covering, and they were using silk remnants from silk manufacturing to try and reinforce it. But silk wasn't actually strong enough, but asbestos was. So that's where this stuff came from, is the magnesia pipe covering, and magnesia was mixed with asbestos. So the next we're going to go over is an advertisement for Boss ovens. Now, I think all of us have used an oven with a glass door, and it's nothing magical to us now, but that was kind of a new invention when this ad was made. In fact, Boss ovens were the very first glass door ovens. And one of the reasons that they were able to do the glass door, I believe, is because of this asbestos lining saves fuel ad. The portion of the door that was lined with asbestos, that's what helped keep the heat in. And that was important for saving fuel. Basically, if your oven is better insulated, less heat gets out, so you're not using as much fuel to do the cooking. So they advertised, like a lot of products did, with it's clearly supposed to be a housewife who's cooking for her family, and she's very happy to have this wonderful stove. What she doesn't know is that every time she opens and closes this door, a lot of very microscopic asbestos fibers could be getting released in the air. So as much as people often like vintage appliances, be very careful if you go buy an old 1940s or 50s stove, because if it's truly original, it will still have asbestos insulation on it, and that could cause health problems later on down the road. You can learn more about the health problems in part 3. Now, the next ad we'll take a look at here is from Union Asbestos and Rubber Company, which is UNARCO, and they had a lot to do with manufacturing insulation in World War II, and they're very proud of that fact. Remember, ad was put out in the middle of the war, and was still an open question as to how the war was going to turn out. They're advertising here that they prevent freezing when things get hot, and that's some flak, got the spotlights, and I believe that's supposed to be a B-17 over Europe. So they're very proud that they got the Army and Navy E awards at 2 of their plants for excellence. Asbestos being used in airplanes, this became a very rich tradition for asbestos. As we've talked about a couple times now, it made it all the way to the moon in Apollo, but a lot of our jet planes, propeller planes, a lot of aerospace applications used asbestos for the same reasons everybody else did. It has the properties of being heat resistant, lightweight, and all of that sort of thing. So just to kind of, as a humorous side, this was so deep in the war. If you turn the back, this is an actual magazine advertisement. This one here is from Budweiser, who's advertising about how the natural B complex vitamins in brewer's yeast are helping keeping our civilian and fighting forces in shape. During the 40s, a lot of advertisements was tied into the war effort, and it touched everyone's days. So in this particular case, average individuals probably wouldn't, in the home use, be using any of UNARCO's products. But if you watch part 4 of the video, you'll get to see how employees of UNARCO in Paterson, New Jersey, were just down the street from Johns Manville, the big asbestos manufacturer. And UNARCO people called up JM, and they're like, hey, we have been discovering some health effects of our employees that are working with asbestos. What have you guys found? And in part 4, you'll find out what happened when they went to the Johns Manville boardroom to share their findings and had a lobster lunch. You'll get to hear how that one turned out. So please watch part 4. I think it's going to be very entertaining for you. The next ad we have to go for is from the company Garlock, who's still in existence today. They make gaskets. They don't make asbestos gaskets anymore, but they sure used to. And this is an early ad that they put out in the teens or 20s. I don't know if it has the date on it. But they put this out advertising that, hey, we've got this great warranty if you use any of our asbestos gaskets. And I looked up the Garlock 950 compressed gasket, and it's absolutely asbestos. And they even say that it was made with Canadian asbestos, probably from the Jeffrey mine, but it could have come from a couple others. So let me show you exactly what an asbestos gasket looks like. What we have here is an asbestos gasket. I don't believe it's a Garlock gasket, but the principle is the same. You can tell they're kind of solid sounding gaskets. It takes a little pressure to twist them. And these are what would have been used in high temperature, high pressure applications, except much larger. This is a pretty small gasket. They made them bigger, and if it was for a really big pipe, a lot of times you'd have to use a sheet gasket and cut it out. But this is what an asbestos gasket would look like. And you can see the white fibers, that's chrysotile asbestos. I'm not particularly worried about the health concerns of being around this, because I'm not grinding on it or cutting it or slashing it or doing anything that could really release the fibers and get them in the air. And also, as you'll learn in part 3, the occasional fiber being breathed in isn't going to be a problem, because in actuality, we're all breathing in asbestos all day, every day, because every city has a background level of asbestos in it. If it's an industrialized city, there's asbestos in the air, some more so than others. But it's very, very small doses. So I'm not going to start grinding on this gasket, and I'm absolutely going to clean up any of the debris that fell. And you can see here a little bit fell here, And here, we're going to get that all cleaned up. We have a HEPA vacuum and we take all the proper precautions. But I want people to see what an asbestos gasket looks like. So if you come across one ever, do not use a wire brush or wheel or grinder or anything like that, because that's what will make the clouds of dust that really truly would be dangerous. So this is an asbestos gasket like we saw advertised. So we talked about some of the advertisements that were used by some various asbestos companies and some non-asbestos companies that were proud they were using asbestos in their product. But now let's talk about a straight up legit asbestos product. This one was called Kaylo, and it was made by Owens Illinois and eventually Owens Corning. As you'll see in the advertisement, Kaylo is advertised as having a lot of advantages over other types of insulation, most of which come down to all the reasons people use asbestos. It's durable, it has good insulating values, it's lightweight, it's not that expensive. These are the kinds of reasons why you would use Kaylo. And we can get a little more in-depth if we go past this advertisement to this brochure that they put out, The Story of Kaylo, First in Calcium Silicate. Now, calcium silicate, this was the first time that they had managed to mix it with asbestos to make a product that could be very industrially useful. So they were proud about this. And they say that the name Kaylo was taken from the symbol K, which is an engineering symbol that means thermal conductivity. It has low thermal conductivity. That means if one end of it's hot, the other end's not necessarily going to get hot. That heat won't go down. You'll see an example of that a little later. And they say that Kaylo is lighter than wood, a better thermal insulator than gypsum, stronger than the common materials used for insulation, and is incombustible as concrete. Kaylo Materials offers exciting possibilities for an almost unlimited number of uses. So Kaylo, as you see on the screen, you see that little sheet that says The Story of Kaylo. That's a sheet of asbestos Kaylo insulation, block insulation. Let's see how they make this. This is the diagram from that little brochure on the left, and you can see that they highlight lime, silica sand, and asbestos fibers. The paragraph on the right is taken from a lawsuit against Illinois, or against Owens Illinois, and Owens Illinois explains how Kaylo is made in some generic terms. Raw materials were delivered to the batch floor. That'd be lime, or quicklime rather, silica sand, and asbestos fibers. The components are then emptied into a mixer that contains water, resulting in a slurry. And they made 30,000 pounds at a time of this, by the way. I've got their internal engineering documents and see how they made it, and they made big batches. The mixture is pumped to forming areas and then molded into various shapes and sizes. Then the forms proceed to the hardening process and then into autoclaves. So what was in Kaylo? Kaylo had multiple types of asbestos. This is Kaylo 10. There were two types of Kaylo, Kaylo 10 and Kaylo 20. You'll see what that meant in a minute. But Kaylo 10 contained AW amosite asbestos, W3 amosite asbestos, 6D chrysotile asbestos, and 4K chrysotile asbestos. Those prefixes, the 4W, the 4K, that is the grade of fiber. If you remember from the mining videos when they were separating the fibers through the screens, they would be grading them, and they're separated based on fiber length. Chrysotile, as you might recall from the first video, has the longest fibers and was very useful because of it. But amosite also had long fibers, not as long, and it was used extensively in insulation products, oftentimes mixed with chrysotile. Here is from their brochure again. You'll see that there's a gentleman standing on the piece of Kaylo, and it's a very lightweight piece of Kaylo. That's part of why this material was used on Navy ships. So you see it says that Kaylo had two variants, Kaylo 10 and Kaylo 20. The numerical designations referred to how much they weighed for a cubic foot. A cubic foot of Kaylo 10 weighed 10 pounds, cubic foot of Kaylo 20, 20 pounds. You've got to understand how light this is in comparison with other materials to really get why they used asbestos so much. A cubic foot of styrofoam weighs 2 pounds, nothing. Freshly fallen snow. Now, I went to law school in Michigan and I was exposed to a lot of snow, so I understand, wow, a cubic foot of snow, that really doesn't weigh that much. But if you weren't around snow, let me give you another example. Sawdust. We've all held some sawdust. A cubic foot of sawdust weighs 17 pounds, but a cubic foot of Kaylo 10 only weighs 10 pounds. This stuff was really, really light, and its lightweight didn't sacrifice its strength, as you can see with the gentleman standing on that. We can show you one of the things that Kaylo was so good at and that they were so proud of. This again from their brochure. In another test, a section of Kaylo material is exposed to flame temperature above 1600 degrees. The surface unexposed to flame remains cool enough to touch with the bare hand for an indefinite period. And it's an older black and white picture. It's not the best, but you can tell that Kaylo 10, that's not that thick, a couple inches maybe, and somebody's putting a blowtorch and you can have your hand on the other side, no problem. 30 seconds after the flame has been removed off of that Kaylo, you could go put your hand where the 1600 degree flame was. This is what was so good about Kaylo as an insulation product. So if Kaylo was so good, which it really was, why do we not use it anymore? Well, it was taken off the market in 1973 because of health risks associated with the product. But I want everyone who's watching this to understand these health risks didn't come out in 1973. Owens, Illinois knew for a fact that their product was deadly. And here's the proof of that. In November 16th of 1948, a gentleman at the Trudeau Foundation for the Saranac Labs, which you'll hear a lot more about in video number 4, that laboratory had been hired to do a safety test on Kaylo. And here's the letter they sent to Owens, Illinois. I realize our findings regarding Kaylo are less favorable than anticipated. What they found is it could cause asbestosis, which you recall can be a fatal disease. However, since Kaylo is capable of producing asbestosis, it is better to discover it now in animals rather than later in industrial workers. Thus, the company, being forewarned, will be in a better position to institute adequate control measures for safeguarding exposed employees and protecting its own interests. It's better to discover it now in lab animals rather than later in humans. But Owens, Illinois went right ahead. They still sold this product, knowing it could cause asbestosis in humans and not putting a warning label on the product. And in part 5, the compensation portion of this video, you'll hear why not putting a warning on it was such a big deal. Other than the obvious moral issue, you guys know this product can kill, you should say something. So when the industry says, oh, we didn't know until the 60s or the 70s and we did everything we could, they are lying. And this letter is just one piece of proof of the lies that they have continued to tell for decades. And you'll hear a lot more of those in part 4. But this part of the video is about all of the different uses of asbestos. So I've reproduced from a book called the Asbestos Fact Book some of the uses of asbestos, and I have a few to highlight to talk about. I'm not going to read them all to you because there's a lot, but they're here for your reference to download. You'll see on this slide we've highlighted space vehicle heat shields. Asbestos was actually used even up until the space shuttle days, and it was used for some of the heat shields on the shuttle itself. So asbestos didn't just stop being used in the 70s. It continued in other applications for much later. Another use here, electrical insulation. In part 1, we showed some patents for electrical insulated wires, and you saw an actual asbestos insulated wire that I have. You see auto body undercoating. Now, if you ever got underneath an older car and you saw it look like a black rubbery coating sprayed, especially cars from like the 60s and 70s, that was a rubberized undercoating that was reinforced with asbestos fibers. So if you're grinding or drilling or sawing or anything on that, be careful and use a respirator. You'll be breathing asbestos. And then the filtration medium for beer, wines, plasma, and sugar. You'll hear more about the beer in a bit. And when they say plasma, they mean blood. Asbestos has been used for blood filtering because what could go wrong with putting asbestos right into the bloodstream, right? That's the kind of things that they used to do with asbestos. Then we go over here on the next slide, asbestos cloth and packing. I wanted to show you, I actually have a sample of cloth that has been turned into asbestos packing. And the same thing applies. As we talked about, very minor, brief exposure. I'm not stressed about. I'm not going to take this out of the box and handle it though. This feels like a rubbery, slick kind of coating. And what people would do is my clients, I have a number of whom worked with this stuff. They'd take the portions off and they'd use scissors or snips or whatever and cut it. And they'd pack it inside of equipment that needed this. And then it would be lubricated. And this would help protect the whatever the equipment was in question. So this is John Crane. They're still around, but they don't manufacture asbestos anymore. And you can see this is braided white asbestos yarn impregnated with TFEs and a special lubricant. So I have no idea how old this particular box is. It's at least 30 years old. And it was something that they call new old stock. I found again on the internet. I like to try to buy this stuff as much as possible to make sure that other people don't come in contact with it. This can be very dangerous, as you'll hear in part 3 when we talk about the health effects. But it's used primarily for valve stems on applications up to 1500 RPM. And good, you can use it for food products. Asbestos was everywhere. On the next slide here, we talks about asbestos clothing, asbestos suits. They use those for fireproofing, so a lot of fire departments wore those. I had one client who brought me a picture of him wearing a fireproof suit when he was working at a refinery. Asbestos gloves were super common. We're going to be making a video about a pair of gloves we got, showing you what they really do and what their uses are. We covered draperies here and theater curtains and motion picture screens because those were big uses of asbestos in like the 30s and 40s and 50s, is they didn't want to have fires in theaters. If you look up on the internet the Iroquois theater fire, that'll tell you a lot about how important asbestos curtains were. And I also mentioned mailbags because I only recently learned asbestos was used in mailbags, and I have found some wonderful pictures of the Postal Service testing mailbags out. If we can get the licensing rights for those, we'll put those up in a video, but was able to see them trying to set mailbags on fire to make sure that if there was a fire, people's mail wouldn't be destroyed. On the next one, we've got covers for laundry and dry cleaning presses. Took people a long time to figure out. Some people working in the dry cleaning industry were developing asbestos-related cancers until they dug and they found out, oh geez, laundry and dry cleaning, super high temperatures. Of course asbestos was involved. That's what you're always looking for, is if it's an older usage where something was hot, asbestos was probably involved. And I have insulation against noise and vibration in aircraft, spacecraft, and buildings. We've already mentioned Apollo and Mercury. May have mentioned that some of the satellites that have their own little nuclear power source, particularly any satellites that had what they called a Fermi reactor, would have been insulated with asbestos. And aircraft. If you guys remember the Concorde, I was never able to fly on it, always wish I could have, but the Concorde, supersonic jet, the window frames around every window was plastic reinforced with asbestos. So asbestos was in places you wouldn't necessarily have known. Asbestos gaskets, we've already shown you asbestos gaskets, and now it says table pads and mats. I've got another thing here to show you, give you an example. This is an asbestos iron rest. Helps protect ironing board and cover, and we have a housewife here who's just so happy that she gets to set her iron on this, which is an iron-shaped asbestos pad. Another safety product of Craft Made Products Co. Well, asbestos is a lot of things, but we know today that it's not safe. But back in the day, housewives were given things like this as trivets for near the stove, pot holders, all sorts of asbestos products found their way into the kitchen to be used for home meal preparation and such. So if you see anything like this, an old-fashioned iron rest that looks like a cloth, it's probably asbestos, and you probably don't want to buy it unless you're somebody like me who wants to get these things off of eBay so no one else uses these and gets sick. Similarly, on this slide, one of the uses of asbestos paper was baking sheets. We've actually have a roll of asbestos paper we're going to be doing some tests with in our lab, and we'll get back to you with another video when we've done with those so you can see what asbestos paper is like and if you really could use it as baking sheets. And you see another one interesting is the lining of safes, stoves, heaters, etc. If you ever remember those cheap $20 or $30 little fireproof lock boxes they'd often sell at like Kmart or Target or grocery stores sometimes, that you could use to keep your family documents in, the lining of those was oftentimes asbestos. We have one of those. We're going to be doing tests on it so you can see exactly which type of asbestos, it's probably chrysotile, and in what percentages. So that's another thing. If you come across an old lockbox and you're going to have to try to pry it open, if it could have asbestos in there, you're going to want to do that with some respirators or some safety protection, because if you break that thing open, it's going to spray a cloud of asbestos dust in your face, and you probably never would have imagined that's what it is. And that's part of the issues with asbestos, is it found its way into uses where people had no idea it was there. Over here on the next slide, it talks about asbestos was used a lot in electrical cabinets and panel boxes and a lot of electrical things, because asbestos is non-conductive. So it was used extensively in electrical uses because you could put it behind a switch panel and it wouldn't catch fire and it wouldn't conduct electricity. So it was super useful for that sort of thing. So some of these are pretty common uses that you could kind of foresee, but what about the uses you would never have guessed? Let's look at a couple of those. Asbestos was in places you'd never expect. And I have a newspaper article from 1966, and it says that asbestos is a mineral highly valued for its non-corrosive and long-wearing properties. Its common use as a fireproof material, makes up 50% of asphalt tile used in dental cement, brake linings, plastics, beer filters, gas masks, and paper. Yeah, they put it in gas masks. The filtering properties of it made it useful for some of the weapons used in World War II. But if you put a gas mask on and you're breathing asbestos, I probably don't have to tell you what a bad idea that would be. And in addition to asphalt tile, it was often used in asbestos floor tiles. And if we could go to the overhead, I'll show you kind of what we're talking about. This is a salesman sample. I have a big box with 20 of these things. It's a salesman sample of vinyl asbestos floor tile. And I think we have all walked on floor tiles that look substantially similar to this stuff. It was used in pretty much every school and industrial office and all of that. If anything looks like this, it's probably asbestos floor tile. And because this is what the industry called locked in or encapsulated, the asbestos isn't going to go anywhere from this unless I start sanding on it or filing it or grinding it. So I have no worries about this stuff at all. So the lesson to you as a homeowner, if you're going to do a home improvement, is if you have floor tile like this and think it's ugly and want to get rid of it, that's great. But make sure proper precautions are taken with an asbestos abatement company so you don't end up putting asbestos all over your house when you scrape it up. So that's what asbestos floor tile would look like. So beer filters. When I first started getting interested in doing asbestos law, I had heard asbestos was used with filtering beer. And I never knew more about it, and it's always sounded really strange to me. So we did some digging. And this from John's Manville talks about that they went to the grocery store and they bought some samples of beer because they knew they were selling asbestos fibers to pretty much every beer company to filter their beer. And they wanted to know, hey, geez, is our asbestos making its way into the beer? Well, it says that visual examination of the electron microscope plates show the presence of some fibers in all samples. Schlitz regular, in particular, seems to contain a large amount of asbestos fibers, and a Budweiser sample was analyzed prior to this more complete study, and it had 2.5 micrograms of fiber per gallon. Now, there's never been any kind of study or anything to show that the minor amounts of asbestos in beer could have led to any sort of digestive or other cancers, but still probably didn't want to be drinking this stuff, and it's a good thing that asbestos is no longer used by major manufacturers to filter their products. To be clear, I do not believe that Budweiser is currently filtering any products with asbestos or any other manufacturer, any other beer manufacturer. So don't take this as some kind of an indictment or attack against a beer company. Everybody used to filter the stuff through it, and now nobody does. But that did give me a really interesting artifact that we're going to do a video on, and that is this beer serving tray. John's Manville, a great name in beer. Well, I guess it was literally in the beer, wasn't it? Because they found asbestos fibers in all of those samples. We'll show you this in a future video and talk about the other weird uses of asbestos. But what was the most heinous use of asbestos? There's been so many of them, but this one to me, I think, is probably the worst. From that same article, until last year, some schools used asbestos dust instead of sand for children to play in. Last year in this instance means 1965. By 1965, the medical professionals had no doubt that exposure to asbestos could cause fatal lung cancer, fatal mesothelioma, another type of cancer, and asbestosis. So you got to be thinking, geez, kids playing in asbestos sand, that had to have hurt some people, right? Well, this isn't theoretical. These children in the 50s in Australia were playing in an asbestos sandbox. And if you visit the URL that's underneath the photo, you can learn more about them. But both of these children were exposed playing in asbestos, and they both died from mesothelioma. This only happened because very terrible people decided to cover up the health risks of asbestos for decades to protect their bottom line instead of protecting everyone else on the planet. So I'm going to end with that somber note because as much interest as I have in asbestos, I don't ever want people to think I take this lightly. Asbestos kills. My father, my grandmother, and my grandfather died of asbestos-related cancers and all had great amounts of exposure to it that led to that. And we're going to talk in the next video about the diseases associated with asbestos use. And until then, I encourage you, if you're working around any product that could have asbestos in it, do take the proper safety precautions, especially if you're working with it industrially.